Hi, class. So here we are, last section of chapter 4, which means your test is coming up really soon. Okay, so section 4.6 deals with word problems. Okay, so applications using exponentials and logs. So, um, you know, not all of them are the same, so it's not like there's one set way. However, uh, they're all basically uh, you have to read the word problems more than once to get a feel for what they're asking for and what it is that you have to answer what they are asking for. Okay, so um, read it a few times until you really understand it, and then see all the bits of pieces of information that you have, and how you can put them all together to solve this problem. Okay, so uh, radioactive decay. So the half-life of strontium-90 is 28 years. How long will it take a 50 milligram sample to decay to a mass of 32 milligrams? Okay, so I should put here that radioactive decay, it turns out, behaves in such a way that it follows this formula. So RT, that's not an N, that's an RT. So you're familiar with this formula from before. Okay, so that's going to be the one we look for. We usually use this for like interest rate problems, but it's for anything that behaves exponentially with this Euler's number. Okay, um, so the initial amount is still P, the final amount is A. Okay, so some pieces of information. How long will it take a 50 milligram sample to decay to a mass of 32 milligrams? So how long will it take a 50 milligram sample to decay to a mass of 32 milligrams? So this here and this here, very important pieces of information. Okay, so here, this 50 milligrams, that's our initial amount. So that's going to be our P value. Okay, and we want to know how long. Okay, so that's going to be T that we're going to be solving for. Okay, so T is what we are solving for. How long will it take a 50 milligram sample to decay to a mass of 32 milligrams? So that's going to be our final amount. Okay, so we have a lot of the information already. So if I use my formula, A equals PE to the RT, and I fill this in, so A is 32, P is 50, E is not a variable, it's Euler's number. Okay. R, we don't have R, and it's asking us to find T. Okay. So T is going to be unknown, and that's going to be the one we look for. Okay, so we're missing R. So this is kind of a big deal because usually we have all the pieces of information. We're only left with one variable that's unknown, and that's usually the one that you have to solve for. Okay, so here we don't know what R is, so we can't actually solve this problem just yet. Okay, because we need to first figure out R. Whenever you see this, half-life, as soon as you see that, it gives you a lot of information. Okay, it says that the half-life is 28 years. Okay, so what it's saying is whatever amount you start with, you end up with half of it in 28 years. Okay, so let's go back to our formula here. So when you have missing variables here to solve the problem, then this actually becomes two problems. Okay, and usually if it's a half-life problem like this, it's probably going to be a two problem type of situation. Okay, so you start off with a certain amount, whatever amount that is, P, and then you end up with half of it, half that amount. Okay. And you end up with half of that amount in 28 years. So t is 28. Okay, so now here it looks like we have two variables and we can't solve for r, but actually if we divide both sides by p, right? If we divide both sides here by p, then they both cancel on both sides. So I end up with 1/2 equals e to the 28r. And now I can actually solve for r. And this r is going to be the r that we need over here. Okay? So let's go ahead and use what we learned from the last section to solve for exponentials. All right, so here, since that's e, I'm going to use ln. Because they cancel out from that one particular property, okay? When the base matches that. Okay, and ln is base e. Okay, so I get ln of 1/2 equals 28r. And then I can solve for r. Divide both sides by 28. Okay, and then now is when you punch it into your calculator. Try not to punch it in early in your work because, again, you don't end up with a more precise answer. Okay, so here it turns out that r is negative 0.02476. Okay, or you could just use all of this, okay, when you punch it in over here. Okay, now some calculators have a feature where you could store this answer because it's longer than this. It actually goes on longer. And so I use my store button to use that answer over here. Okay, so if you have that feature, then definitely use it. Okay, all right, so now that we know our R value, okay, we can go ahead and plug it in over here. So 32 equals 50e to the, and it's usually an answer button. Okay, so check on your calculator and see if you have that. Answer times t. Okay, it's this, whatever this answer. This is my ANS. So look for that button. Okay. And now we can solve for t. So divide both sides by 50. 32 over 50 equals e to the answer times t. Okay, and now I have to solve for an exponent, so I'm going to take the log of both sides. So I'm going to take the log of this side and the log of this side. Okay, and then over here, it's like these guys cancel out. So I get ln 32 over 50 equals your answer times t. Okay. And now you can solve for t, divide by this on both sides. And you should get 18.03 equals t. Okay. So this is probably the most complex of the exponential problems that you'll have to solve, these word problems here, where you have the two parts. You'll have to maybe do this part before you can actually solve the problem. Okay, but this isn't most problems. I just kind of wanted to start with this kind. Okay. But if you don't have this button to store this answer, then feel free to use this here, plug that in the whole ln 1/2 over 28. Use that to plug in for r over here. Okay. Okay. So let's take a look at this. We've looked at investment problems before, but you never had to solve for the exponent. So let's take a look here where you do. Okay, so Harold and Maude invest $3,000 into an account that pays 4.7% interest. It's compounded continuously. How long will it take for them to double their amount? Okay, so we have a lot of information here. Harold and Maude invest $3,000. So right here, this is going to be your principal amount into an account that pays 4.75% interest. So right here, this is going to be your R value. Compounded continuously. So continuously tells me I'm using which formula? The longer one or the short one? Because remember the interest problems, we had two formulas, a short one and a longer one. Okay, so when it's compounded continuously, we're using this one. Okay, how long? So that's t that we're trying to find. How long will it take for them to double their amount? Double their amount, so the final amount is going to be, well, if our initial amount is 3,000, then our final amount needs to be 6,000. Okay. All right, so let's take a look. A equals PE to the RT. Okay, so let's go ahead and plug in all of our values. And this one over here, before I get going on it, this one is our A value, our final amount. Okay. All right, so we want to end up with $6,000 when we invest 3,000. Okay, we're trying to double our amount. And our interest rate is 0.0475. Because remember, you have to write it in decimal form, not percent form. Okay, times t, which is unknown. Okay, so we have this exponential that we need to solve for. Going to divide both sides by 3,000. There is a formula somewhere in the book, I think, but you know, who wants to memorize another formula? Okay, so over here we get 2 equals e to the 0.0475t. Okay, and now I have my exponential by itself, so I'm going to take the log of both sides. Again, since that's e, whenever you have e, even though you have two choices on your calculator, log base 10 or ln, log base e, you have two choices. Whenever you have e there, just go ahead and use ln. Okay, so I'm going to take ln of 2 because then that actually cancels these guys out. Okay, and that only works with the e and 10 because those are the only two you have on your calculator. Okay, ln 2 equals 0.0475t, and now I can solve for t. All right, and when we punch this into our calculator, we get 14.6 years. Okay. So these are more typical of the types of problems to expect. Okay. All right, go ahead and try this one and come back and check your answer. Okay, so see if you can pick out all the pieces that are necessary to solve. Okay, so go ahead and hit the pause button, try this out, and then come back. Okay, so if you got 9.9 years, then you are correct. If you did not get 9.9 years, then let's take a look here. All right, Jack and Diane invest $12,000. Okay, so here, let me pick a different color. Okay. All right, so this $12,000, this is your initial investment into an account that pays 5.2% interest. That's your rate. Compounded quarterly. Compounded quarterly, that tells you which formula you're going to use, PERT or the longer one. And so since it does not say continuously, you're going to be using the other one. A equals P times 1 plus R over N to the NT. Okay, so that one. Okay, compounded quarterly. Okay, compounded continuously is the PERT. Okay, how long will it take? So this is telling me that I need to solve for T. And for the final amount to be 20,000. So final amount. All right, and quarterly N is 4. Okay. All right, so let's write down our formula over here and work this out. A equals P times 1 plus R over N. Make sure your R's and N's look different from each other. Okay, so final amount, 20,000. Initial amount, 12,000. 1 plus interest rate, 0.052 over N, that's 4. And then to the 4 times T. T is the one that's unknown. Okay. Okay, so here you can divide both sides by 12,000. Okay, and I like to do most of it by hand before I start introducing the calculator, so that becomes 5 over 3. And then 1 plus 0.052 over 4 to the 4t. Okay, now that the thing with the exponent is by itself, I can take the log of both sides. I'm still going to use ln even though I don't have e there. Okay, you can use log base 10 if you want to. Again, it doesn't matter which log you use. So I'm going to do this one to both sides. Okay. And then that allows me to bring the exponent down to the front over here. So 4t ln of whatever this turns out to be. Okay, and here is t squeezed in the middle there, but that's all multiplication. So I'm going to go ahead and divide both sides by the 4 to cancel out the 4, and also by the ln of all of this. Okay, so that'll cancel out this and this, but I have to do it on the other side as well. Multiply by 4 ln 1 plus 0.052 over 4. Okay. And when you punch that into your calculator, you should get 9.9 years. Okay. Okay, so that is basically it. So again, if you have any questions, Feel free to email me. If you have any questions about the other sections as you start studying for your test, you can email me those questions as well, okay? Or send me a message through the Remind thread. Okay, so that'll do it. Study, keep up with the homework, and your test will be online as well, okay?